Okay, students, so welcome to Prime Factorization Part 1. Okay, so today's objective is I can identify factors of a number. Okay, so let's start with some vocabulary. Our first vocabulary word is prime number. Prime numbers. Prime numbers are natural numbers. For example, 2, 3, and 4. Well, 4 is a natural number, but it's not a prime number. We'll get to that in a minute. Okay, it's also divisible by 1 and itself only and it's greater than 1. Okay, so let's list out a couple prime numbers. We talked about 1, it is not a prime number because 1 is divisible by only itself, but 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number. Is 9 a prime number?
I'm not sure, Miss Gomez.
Well, I can't say it's all odd numbers because 2 is not odd. 3 is odd. 5 is odd. 7 is odd. But now I don't think 9 can be a prime number because 9 is divisible by more than 1 in itself. Okay, and when I say it's divisible by, I mean it can be divided by more than 1 in itself. Okay, so not all odd numbers are prime numbers. So don't forget that. Not all prime numbers are odd numbers, so don't forget that. Okay, let's talk about the next vocabulary word, which is composite number. Composite number is a natural number that is divisible by more than 1 in itself. Okay, so I know you guys see natural numbers, and I know you're probably thinking, what is a natural number? A natural number is a what, Miss Garcia?
A natural number is a counting number. For example, when we are counting things with our fingers, we say 1, 2, 3, 4, and so on. We never start with 0.
Okay, so natural numbers are just regular numbers. They're not negative.
They're not negative, they're positive, and they're whole.
Okay.
Positive whole numbers, excluding 0, not 0.
Alright, so composite numbers are natural numbers, or a natural number that is divisible by more than 1 in itself. For example, let's look at that number 9 that we were talking about. 9. Even though it's odd, it's not prime, it's composite because it's divisible by 1, 3, and 9. Okay, so that would be a composite number.
What about the gaps in here, Miss Gomez?
4 could also be 1. Because 4 is divisible by 1, 4, and 2.
What about 6?
I don't know, class. How about for your example, you explain whether 6 is a prime number or a composite number, and why? So you can show me with words in a sentence, or you can show me with numbers. Just make sure that you highlight your answer. Okay? So let's add one more vocabulary word. This one should be super easy. Let's do factors. Factors are whole numbers that are multiplied to find a product.
Miss Gomez, I forgot what a product is.
Product. Product means when we multiply. Okay, so for example, when we multiply 2 times 3, the product is 6. So again, if, for example, if we multiply 2 times 3, the product is 6. So the factors of 6 are 2 and 3.
Okay, I think I get it.
Okay, so let's try we're going to do something called prime factorization. Prime factorization is the number written as the product of its prime factors. Prime factorization is the number written as the product of its prime factors. Okay, so you see the word product, and remember product means to multiply, and it's prime factors, so the prime factors. Okay, so let's do an example of prime factorization. Let's do the prime factorization of 20. And what we're fixing to do right now is called the factor tree. Okay, I know it doesn't really look like a tree, but you could make it look like a tree. Okay, so what 2 numbers can we use to make 20? Let's try 5 and 4. Okay, are one of those a prime number? And you used to say, yes, Miss Gomez, one of those is a prime number. Okay, you circle the prime number. And, okay, so I'm assuming you circled 5. 5 is a prime. Okay, is 4 prime? No, it's a composite number. What 2 numbers did we use to make 4? And 2. And 2. And are those 2 2's prime? I believe so. Check it out. Okay, so we're going to circle those. And we're done. Okay, so let's write it out. We have 2 times 2 times 2 times, 2 times 2 times 5. Okay.
2 times 2 times 5.
And that equals 20. So it is prime factorization is the number written as the product, multiply, the product of its prime factors. Prime. Okay, so this is a factor tree. Okay, so I want you to see if you can do your own factor tree over here for 24. So be sure to highlight yours. And I believe that is all for today, students. Unless Miss Garcia, do you have anything else to add?
Nope, just make sure that you write down your answers and highlight them for us tomorrow.
All right. Have a great night. We'll see you in the morning. Make sure to check with a neighbor when you get to school and say, "Hey, did you watch your notes?" Well, let's go watch our notes in the library right now. Have a good night. Bye again.